Pioneer 0 to Luna-1 number 3. The race to the moon began with a series of spectacular failures. In the frantic months of 1958, both the United States and the Soviet Union hurled a volley of probes at our nearest celestial neighbor. The U.S. Air Force's Pioneer 0, 1, and 2, and the U.S. Army's Pioneer 3 all failed to reach the moon due to rocket malfunctions. At the same time, the Soviet Union's first 3 secret attempts, known as Luna-1 number 1, 2, and 3, also ended in launch explosions. This brutal opening chapter proved that just escaping Earth's gravity was a monumental challenge. Luna-1. This was the first spacecraft to achieve a partial success. Launched by the Soviet Union in January 1959, Luna-1's goal was to be the first object to physically impact the moon. It successfully escaped Earth's gravity, becoming the first human-made object to do so. However, due to a guidance error, it missed its target, flying within about 3,700 miles of the moon before entering a permanent orbit around the sun, where it was nicknamed Mekta, or Dream. Pioneer 4. NASA's response to Luna-1. Launched just 2 months later in March 1959, Pioneer 4 had the same goal of a lunar flyby. It successfully completed its mission, passing the moon at a much greater distance of about 37,000 miles. It returned valuable data on lunar radiation before it, too, entered a permanent solar orbit. While a success, its greater flyby distance was seen as less impressive than the Soviet near miss. Luna 2. A resounding and historic success for the Soviet Union. On September 14, 1959, Luna 2 achieved what its predecessor could not. It successfully impacted the surface of the moon, becoming the first human-made object to ever make contact with another celestial body. The probe carried Soviet pennants that were scattered across the impact site, symbolically claiming the first major victory in the robotic race to the moon. Luna 3. Just weeks after the triumph of Luna 2, the Soviets achieved another spectacular first. Luna 3 was an advanced photographic mission launched in October 1959. It successfully flew around the moon, and using its onboard camera system, it took the first ever photographs of the moon's mysterious, unseen far side. The grainy, indistinct images it transmitted back to Earth were a revelation, showing a surface very different from the near side, and cementing the Soviet Union's early dominance in lunar exploration. Luna-1A, number 1 to Pioneer P3. Despite the major successes of 1959, the year was still littered with failures that highlighted the unreliability of early rocketry. The Soviet Union's attempt to repeat the success of Luna 3 with Luna-1A number 1 ended in a launch failure. At the same time, NASA's ambitious next-generation Pioneer P series of orbiters, Pioneer P1 and Pioneer P3, both ended in catastrophic launch vehicle explosions. Luna 1960A to Pioneer P31. The year 1960 was a brutal one for lunar exploration, with every single attempt by both superpowers ending in failure. The Soviet Union's first attempts to send a lander, Luna 1960A and 1960B, both failed to even reach Earth orbit. NASA's 2 attempts to launch a lunar orbiter, Pioneer P30 and Pioneer P31, also met with disaster, one exploding on the launch pad and the other failing in orbit. The complete lack of success in 1960 served as a harsh reset for both nations. Ranger 3 to Ranger 6. This was NASA's first attempt to get close-up images of the moon. The Ranger probes were kamikaze missions designed to take as many pictures as possible before crashing into the surface. The early attempts were heartbreaking. Ranger 3 missed the moon entirely. Ranger 4 successfully impacted the moon, but its systems had failed, so it sent back no data. Ranger 5 also missed the moon, and Ranger 6 successfully impacted its target, but its camera system failed to turn on. Sputnik 25 to Luna 4. While NASA struggled with its Ranger probes, the Soviet Union was having its own string of failures with its first-generation landers. Sputnik 25 failed to leave Earth orbit. An unnamed lander, Luna E-6 No. 3, also failed to leave Earth orbit. Luna 4, launched in 1963, successfully got on a path to the Moon, but its mid-course correction engine failed, causing it to miss the Moon by thousands of miles. Ranger 7 to Ranger 9. After a long string of failures, NASA's Ranger program ended in triumphant success. Ranger 7, 8, and 9, all launched between 1964 and 1965, performed their missions flawlessly. In the final minutes before their planned impacts, they transmitted thousands of stunning, high-resolution images of the lunar surface, revealing craters and details with a clarity never before seen. These missions were a crucial success for NASA, providing the essential data needed to plan the upcoming Surveyor and Apollo missions. Luna, 1964, A to Luna 8. While NASA was succeeding with its Ranger impactors, the Soviet Union endured a brutal string of failures in its attempt to achieve the much more difficult goal of a soft landing. Between 1964 and 1965, 7 consecutive lander missions failed. Luna, 1964, A, Cosmos 60, and Luna, 1965A, all failed to even leave Earth orbit. The next 4 probes, Luna 5, 6, 7, and 8, all successfully reached the Moon, only to suffer various technical failures during their descent, with all of them crashing into the lunar surface. Zond 3. This Soviet probe was originally a Mars probe that missed its launch window. Repurposed for a lunar mission, it became a stunning success. Launched in July 1965, Zond 3 flew past the Moon and took a series of spectacular, high-quality photographs of the far side, capturing the areas that Luna 3 had missed. The mission was a crucial demonstration of the Soviet Union's deep space photography and communications capabilities. Luna 9. After years of heartbreaking failures, the Soviet Union achieved a monumental victory. On February 3, 1966, Luna 9 successfully performed the first-ever robotic soft landing on another celestial body. It touched down in the Ocean of Storms and immediately began transmitting the first panoramic images ever taken from the surface of the Moon, giving humanity its first glimpse of the lunar landscape from the ground up. Luna 10. Just 2 months after the triumph of Luna 9, the Soviets achieved another spectacular first. In April 1966, Luna 10 successfully fired its retro rockets and became the first spacecraft to ever enter into orbit around the Moon. Its mission was to study the lunar environment from orbit, and it famously broadcast the communist anthem, the Internationale, from lunar orbit to the 23rd Congress of the Communist Party. Surveyor 1. This was America's response to Luna 9 and a resounding success. In June 1966, just 4 months after the Soviet landing, NASA's Surveyor 1 performed a flawless soft landing on the Moon. Its primary mission was to prove the landing technique and to test whether the lunar soil was firm enough to support the weight of the upcoming Apollo landers. It transmitted over 11,000 images, quieting the fears that a lander might sink into deep dust. Cosmos 111 to Luna 13. Following their initial successes, the Soviets launched a new wave of orbiters and landers between 1966 and 1967. This series was a mix of failures and triumphs. Cosmos 111, Luna 1966A, and Luna 1966B were all failed attempts to send orbiters. However, Luna 11 and Luna 12 were successful orbiters that continued to map the Moon. The final mission of the series, Luna 13, was another successful soft lander, touching down in December 1966 and using a robotic arm to test the soil's mechanical properties. Lunar Orbiter 1-5. This was NASA's critical mapping program in preparation for Apollo. Between 1966 and 1967, 5 Lunar Orbiter spacecraft were sent to the Moon with one primary goal: to photograph and map the entire lunar surface in high resolution to identify and certify safe landing sites for the Apollo missions. The program was a spectacular success, mapping 99% of the Moon and providing the detailed images that allowed planners to select the historic landing site at Tranquility Base. Surveyor 2-7. This was the follow-on to the successful Surveyor 1. The program was mostly successful but not without failure. Surveyor 2 crashed after a thruster failed. Surveyor 4 was lost just moments before touchdown. However, Surveyor 3, 5, 6, and 7 all made successful soft landings. These missions provided invaluable ground truth data, with Surveyor 3 famously being visited by the Apollo 12 astronauts a few years later. They tested the soil, took thousands of pictures, and proved that landing on the Moon was a repeatable, reliable process. Explorer 33 to Explorer 35. These two NASA probes were not designed to look at the Moon itself, but to study the space environment around it. Explorer 33 was intended to be an orbiter, but was sent into a high Earth orbit that passed the Moon after a rocket overperformance. Explorer 35, launched in 1967, successfully entered lunar orbit. Together they studied the solar wind, interplanetary magnetic fields, and how they interacted with the Moon, providing crucial data on the deep space environment that the Apollo astronauts would have to travel through. Zond 1967A to Zond L1S2. This was the Soviet Union's top-secret crewed circumlunar program, designed to beat Apollo 8 around the Moon. The public only saw Zond probes, but these were actually uncrewed test flights of the Soyuz 7KL-1 spacecraft. The program was plagued by failures of its powerful Proton rocket, with Zond 1967A, 1967B, 1968A, 1969A, and the L-1S test flights all ending in launch explosions. While Zond 5 and Zond 6 successfully looped around the Moon and returned to Earth, with Zond 5 carrying the first tortoises in deep space, their descents were flawed. Only Zond 7 and Zond 8 completed fully successful missions, but by then, the race had already been lost. Luna 14. Launched in April 1968, this Soviet orbiter was a successful engineering and science mission. Its primary goal was to test communication systems in support of the Zond crewed program. It also studied the Moon's gravitational field and the space environment around it, continuing the work of the earlier Luna orbiters. Luna 1968A to Luna 1970B. While the world watched Apollo, the Soviet Union was desperately trying to achieve a robotic sample return to upstage the human landings. This led to a brutal string of failures, many involving the secret, powerful N-1 Moon rocket. Luna 1968, A failed to orbit. Luna 1969, A carried the first Lunokhod rover but was lost in an N-1 rocket explosion. Luna 1969B, 1969C, Cosmos 300, Cosmos 305, 1970A, and 1970B were all failed attempts to either orbit or land, showing the immense technical struggle of this highly ambitious program. Luna 15. This was one of the most dramatic missions of the entire space race. A robotic sample return probe, Luna 15 was launched by the Soviet Union just 3 days before Apollo 11. It successfully entered lunar orbit and was circling the Moon at the same time that Neil Armstrong and Buzz Aldrin were on the surface. As the world listened to the Apollo crew, Soviet Mission Control was preparing their own probe to land, grab a sample, and race back to Earth. In a tense finale, just as the Apollo crew was preparing to depart, Luna 15 began its descent, but crashed into the Sea of Crises. Apollo. This was NASA's historic effort to land humans on the Moon and return them safely to Earth during the space race. Over the course of the program, it developed the Saturn V rocket, the lunar module, and the systems needed for deep space human travel. ultimately placing 12 astronauts on the lunar surface and bringing back vast scientific samples and data. If you want a full mission-by-mission breakdown, I have a separate video that covers every Apollo flight in detail. Luna 16. After losing the human race, the Soviet Union achieved a stunning robotic victory. In September 1970, Luna 16 successfully performed the first ever automated sample return from another world. The lander touched down in the Sea of Fertility, automatically drilled into the surface, collected a 101-gram core sample, placed it in a small return capsule, and launched that capsule back to Earth for a successful recovery. It was a monumental technological achievement. Luna 17 and Lunokhod 1. Just 2 months after Luna 16's success, the Soviets unveiled another spectacular first. The Luna 17 lander successfully touched down in November 1970 and deployed Lunokhod 1, the first robotic rover on another world. Nicknamed the Moonwalker, the large 8-wheeled rover was driven in near real time by a team on Earth. It operated for 10 months, traveling over 10 kilometers and sending back thousands of images, pioneering the field of planetary roving exploration. Luna 18 to Luna 1975 A. Even with their Lunokhod and sample return successes, the Soviet program remained fraught with risk. This period saw several more failures in the sample return effort. Luna 18 successfully reached the Moon in 1971 but crashed during its landing attempt. Luna 23 in 1974 landed successfully, but its drill was damaged, preventing a sample collection. 2 other missions, one in 1971 on a modified N-1 rocket and Luna 1975A, failed during launch. Luna 19 to Luna 22. While the landers had mixed success, the Soviet orbiter program continued to be a solid workhorse. Luna 19, launched in 1971, and Luna 22, launched in 1974, were long-duration science orbiters. They spent years mapping the Moon's gravitational field, studying the radiation environment, and taking detailed photographs of the lunar surface. Luna 20. This was the second successful Soviet robotic sample return. Launched in February 1972, Luna 20 landed in a rugged, mountainous highland region, a much more difficult target than the flat plains where Luna 16 had landed. It successfully collected a sample of this different type of terrain and returned it to Earth, providing scientists with a valuable comparison to other landing sites. Luna 21 and Lunokhod 2. The sequel to the first rover was even more impressive. Delivered by the Luna 21 lander in January 1973, Lunokhod 2 was a faster and more advanced rover. Over just 4 months, it traveled an incredible distance of over 42 kilometers, or 26 miles, a planetary roving record that stood for over 40 years. Its mission ended abruptly when it accidentally drove into a crater and its solar panels were covered in dust, causing it to overheat. Explorer 49. This was a unique NASA science mission launched in 1973. Its goal was radio astronomy. By placing it in orbit on the far side of the Moon, the spacecraft was shielded from the constant radio noise generated by Earth. This allowed it to use its long antennas to study faint, low-frequency radio signals coming from the Sun and the center of our galaxy. Mariner 10. While its primary targets were Venus and Mercury, the Mariner 10 probe performed a flyby of the Moon in 1973. This was the first time the Moon was used for a gravity assist maneuver, a slingshot, to help the probe get to its next destination. The flyby also served as a valuable opportunity to test and calibrate its cameras and science instruments. Luna 24, the grand finale of the Soviet lunar program. In August 1976, Luna 24 became the third and final successful Soviet sample return mission. It landed in the Sea of Crises and used an improved drill to collect a core sample from 2 meters beneath the surface. After its successful return, it marked the end of an era, becoming the last spacecraft to soft land on the Moon for nearly 40 years. Ice. After a long hiatus in lunar exploration, the first spacecraft to return to the Moon's vicinity did so by accident. The International Cometary Explorer was a repurposed solar observatory that had just completed the first ever flyby of a comet. In 1983, mission controllers guided it through a series of complex maneuvers, including a distant flyby of the Moon, to place it in an orbit where it could observe the solar wind upstream of the Earth. Hiten and Hagoromo. This was Japan's first ever lunar mission, and a groundbreaking technical achievement. Launched in 1990, the Hiten probe's main goal was to test complex, low-energy transfer trajectories. It successfully released a tiny orbiter named Hagoromo, though its transmitter failed. Hiten went on to perform multiple lunar flybys, and was the first probe to demonstrate the technique of aerobraking in Earth's atmosphere. It ended its mission by being deliberately crashed into the lunar surface in 1993. GEOTAIL. A joint JAXA/NASA mission, GEOTAIL was designed to study the Earth's magnetic tail. To do this, it was placed in a high, looping orbit that involved multiple close flybys of the Moon between 1992 and 1993. Like ICE and Hiten, its lunar encounters were a means to an end, using the Moon's gravity to shape its orbit for its primary scientific mission of studying Earth's magnetosphere. Wind. Another NASA spacecraft designed to study the solar wind and Earth's magnetosphere. Launched in 1994, the Wind probe used a lunar gravity assist flyby to help place it in its unique halo orbit at the L1 Lagrange point between the Earth and the Sun, a perfect vantage point for its primary mission. Clementine. This was a revolutionary mission that reopened the Moon for science. A joint project between NASA and the Department of Defense, Clementine was designed to test advanced, lightweight military sensors by pointing them at the Moon. In 1994, it entered a polar orbit and systematically mapped the entire lunar surface in multiple wavelengths of light for the first time. Its most famous and controversial discovery was the data from its bistatic radar experiment, which suggested the presence of water ice in the permanently shadowed craters at the Moon's south pole. HGS-1. This mission was a remarkable feat of improvisation. The commercial communications satellite HGS-1 was left in a useless low orbit after a rocket malfunction. In a stunning display of orbital mechanics, its operators used the spacecraft's own thrusters and multiple gravity assist flybys of the Moon in 1998 to slowly raise its orbit, successfully rescuing the satellite and placing it in its correct geostationary position. Nozomi. Japan's first Mars probe, Nozomi, was launched in 1998, but suffered a malfunction that left it short on fuel. To try and save the mission, it was placed on a long, looping trajectory that involved 2 gravity assist flybys of the Moon to help it gain the energy needed for its journey to Mars. Lunar Prospector. NASA's first dedicated lunar science mission in 25 years. Launched in 1998, this small, simple orbiter was designed to follow up on the hints of water ice from Clementine. Its neutron spectrometer created the first global maps of the distribution of various elements across the lunar surface, and it famously detected high concentrations of hydrogen at both poles, strong, definitive evidence for the presence of water ice. The mission ended with a planned crash into a polar crater in an unsuccessful attempt to kick up a detectable water plume. WMAP, the Wilkinson Microwave Anisotropy Probe, a NASA cosmology mission designed to map the afterglow of the Big Bang, used a lunar gravity assist flyby after its launch in 2001. The maneuver was critical for helping the spacecraft get to its final observing post at the L2 Lagrange point, far beyond the Moon. SMART-1, the European Space Agency's first mission to the Moon. Launched in 2003, SMART-1 was primarily a technology demonstrator. Its key objective was to test a new, highly efficient solar electric ion engine. The The probe spent over a year slowly and gently spiraling outward from Earth until it was finally captured by the moon's gravity. After entering orbit, it conducted scientific observations of the surface until its planned impact in 2006. Stereo-A plus Stereo-B. This pair of NASA solar observatories, designed to get a 3D view of the Sun, used lunar gravity assists after their launch in 2006. The two spacecraft, Stereo ahead and Stereo behind, flew by the Moon on different paths, which slingshotted them into their respective orbits, one leading ahead of Earth and one trailing behind. SELENE/Kaguya. Japan's 2007 orbiter reopened the Moon for modern, high-quality mapping. Kaguya ran a sweeping survey of the surface and environment, while the two tiny sub-satellites, Okina and Una, improved radio tracking and gravity measurements. It delivered a huge baseline dataset for later missions before a planned impact in 2009. Chang'e 1. China's first lunar orbiter, launched in 2007, proved it could navigate to the Moon, hold lunar orbit, and return serious science. It mapped the surface and gathered key topography and composition data that would feed directly into later landing plans. It was the opening move of a long, step-by-step program. Chandrayaan-1. India's first lunar mission entered orbit in 2008 and began mapping with a mix of Indian and international instruments. Early on, it released the Moon Impact Probe, which struck the surface after collecting data during descent. Chandrayaan-1's biggest legacy was strengthening the case that water-related molecules exist on the Moon, especially near the poles. LRO. Since 2009, LRO has been the reference map layer for basically everything: landing safety, terrain hazards, lighting, temperatures, and polar shadowed regions. It's the mission that turns interesting spot into we know exactly what's there, and it keeps updating that picture year after year. LCROSS. In 2009, NASA slammed a spent rocket stage into a permanently shadowed polar crater to kick up a plume, then flew the LCROSS spacecraft through it to analyze the debris. The results showed clear signs of water in the excavated material, turning polar ice from a theory into something you can plan around. Chang'e 2. Launched in 2010, Chang'e 2 delivered sharper mapping than Chang'e 1 and helped refine targets for future landings. After its lunar work, it continued with extended deep space operations, proving China could keep a spacecraft productive well beyond the main mission. THEMIS. Two NASA spacecraft were repurposed into lunar assets, using the Moon's gravity to reshape their orbits. Their job became studying the plasma and particle environment around the Moon, the exact space weather conditions that matter for long-term lunar operations. It's a great example of squeezing extra value out of existing hardware. GRAIL-A plus GRAIL-B. In 2012, the twin GRAIL probes mapped the Moon's gravity with extreme precision by tracking tiny distance changes between them as they flew in formation. That produced the best gravity map ever made, revealing hidden structure beneath the crust. After the data run, both were intentionally impacted. LADEE. LADEE arrived in 2013 to study the Moon's ultra-thin exosphere and dust environment, which matters more than it sounds if you care about surface operations. It also tested laser communications, proving fast data links beyond Earth orbit. The mission ended with a planned impact in 2014. Chang'e 3. In late 2013, China achieved a controlled soft landing and deployed its U-2 rover, proving real surface capability. Even with rover issues later on, the mission returned valuable science and, more importantly, engineering lessons about surviving and operating on the lunar surface. Chang'e 5T1. This 2014 mission was essentially a re-entry test for a future sample return. It flew a lunar loop and brought a capsule back to Earth at high speed, validating a critical technology chain China would need to actually return lunar material. 4M. A tiny Luxembourg-built spacecraft that hitched a ride and turned into a long-running deep space experiment. It demonstrated that even very small secondary payloads can do meaningful operations far from Earth, and it kept going years beyond expectations before ending in 2022. TESS. TESS wasn't a moon mission, but in 2018, it used a lunar gravity assist to help shape its unique observing orbit. It's a clean example of the moon acting as a navigation tool for missions headed somewhere else. Queqiao. China's farside missions needed a communications bridge because the moon blocks direct radio contact with Earth. Queqiao solved that in 2018, enabling continuous relay links for farside surface operations. Longjiang-1 plus Longjiang-2. These small companion spacecraft rode along with China's farside architecture as add-on technology and science satellites. One was lost early, but the surviving satellite showed how small sats can operate around the moon and support extra experiments beyond the main mission. Chang'e 4. In 2019, China became the first to soft land on the moon's far side, using relay support to stay connected. U-22 began a long traverse and steady science campaign, turning a once radio-silent hemisphere into a working destination. Beresheet. Israel's privately backed lander reached lunar orbit in 2019, a major milestone for a small-budget mission, but it failed during final descent and crashed, showing that the last minutes of a landing are still where missions go to die. Chandrayaan 2. In 2019, India's lander and rover were lost during descent, but the orbiter entered lunar orbit successfully and continued returning data. The mission became a mix of setback and progress. The landing failed, but the orbital capability was real and enduring. Chang'e 5. In 2020, China pulled off the first lunar sample return in decades, completing the full chain: land, collect, launch from the moon, rendezvous, and return to Earth. It instantly refreshed lunar science with new material from a new site, and parts of the mission continued operating after the return. Artemis. This is NASA's modern return-to-the-moon architecture, designed to build a long-term presence instead of a one-off landing era. It includes Pathfinder missions like Capstone to validate key orbits, the uncrewed Artemis 1 flight that tested Orion around the moon, and a wave of secondary CubeSats meant to scout, experiment, and prove small deep space capabilities. I already covered the full Artemis story in detail, so if you want the complete breakdown, check out my other video that explains the Artemis program step by step. Danuri. South Korea's first lunar mission entered lunar orbit in December 2022 and began operating as a modern science and technology demonstration orbiter. It's the classic build competence first step before attempting more complex lunar operations. Lunar Flashlight. A small NASA CubeSat meant to search for surface frost in permanently shadowed polar regions using laser reflectance. Propulsion problems prevented it from reaching its intended lunar orbit, and NASA ended the mission in 2023. Hakuto-R Mission 1. iSpace's first landing attempt reached lunar orbit in 2023 with high-profile payloads on board, but it failed during descent and crashed. The mission still proved the company could navigate to the moon, but it also exposed how thin the margins are in the final landing phase. Chandrayaan-3. India's 2023 return succeeded with a controlled soft landing and rover deployment. It proved India could stick the landing after Chandrayaan-2's failure, and it delivered real surface operations and measurements from a high-interest region. Luna 25. Russia's post-Soviet era return to lunar landing ended in 2023 when Luna 25 suffered a failure during operations around the moon, and impacted the surface. It was a blunt reminder that landing capability doesn't survive on legacy alone. SLIM. Japan's SLIM landed in January 2024 and demonstrated extremely high landing precision, then deployed 2 tiny explorers. Even after landing in an awkward orientation, it kept producing results and survived multiple lunar nights before contact was finally lost. Peregrine, Astrobotic's first CLPS delivery, suffered a major anomaly after launch and never reached the Moon. The mission ended with a controlled re-entry over the South Pacific in January 2024, closing out a high-profile commercial setback. IM-1 Odysseus. Intuitive Machine's first lander reached the surface in February 2024, but tipped onto its side, limiting communications and operations. Even so, it returned data for several days and marked a major commercial milestone in getting a private lander down on the Moon. DRO-A plus DRO-B. China launched this pair to demonstrate operations in the Earth-Moon region using distant retrograde orbits. A launch anomaly forced a long recovery campaign, but the satellites ultimately reached their intended regime and later supported links with a third spacecraft, validating the constellation concept. Queqiao 2. Launched in March 2024, Queqiao 2 is an upgraded relay built to support far-side and polar missions, starting with Chang'e 6. 2 small test satellites, Tiandu-1 and Tiandu-2, flew with it to help test future Earth-Moon communications and navigation techniques. Chang'e 6. In 2024, Chang'e 6 returned the world's first samples from the Moon's far side, bringing the return capsule down in Inner Mongolia. It was a major leap, because far-side sample return adds extra difficulty in communications, operations, and timing. JUICE. ESA's JUICE used the Moon as part of its long, fuel-efficient route toward Jupiter. The lunar encounter wasn't about lunar science. It was about shaping the spacecraft's interplanetary trajectory with gravity assists. Blue Ghost Mission 1. Firefly's first lunar mission launched in January 2025 and soft-landed in Mare Crisium in early March, delivering NASA payloads and operating as a stable, upright lander. It became a clean commercial, it-worked story in the CLPS era. Hakuto-R Mission 2. iSpace's second attempt reached lunar orbit and went for landing in June 2025, but contact was lost during descent, and the spacecraft impacted the surface. The company later pointed to a laser rangefinder anomaly as a likely cause. IM-2 Athena. Intuitive Machines returned in 2025 aiming for a south polar landing and briefly operated payloads after touchdown. Images confirmed Athena was on its side inside a crater, which quickly killed power margins and ended the mission early. Lunar Trailblazer. This NASA smallsat launched in February 2025 to map lunar water from orbit, but controllers lost contact about a day later. After months of recovery attempts, NASA officially ended the mission in 2025. Odin. Astroforge's Odin launched in early 2025 as a rideshare headed for an asteroid flyby mission, using cislunar space as part of its departure corridor. Communication problems hit soon after launch, and the company declared the spacecraft lost, cutting the mission short. Chimera GEO-1. Epic Aerospace's Chimera GEO-1 was an orbital transfer vehicle launched on a trajectory that included a lunar flyby in March 2025. It received some telemetry, but couldn't reliably receive commands, and after the flyby it failed to reshape its path as planned, drifting into a solar orbit instead. Thanks for watching. Which mission do you think mattered most? The first impact, the first landing, the first human step, or the first return to the far side? Let me know in the comments. Also, please remember to like and subscribe if you enjoyed this video.